In this video, we have some additional examples of linear regression in action. We'll be using the data sets that you can see in front of you on the screen. Number 27, male versus female drivers. Should look familiar. We used it a couple of videos back for scatter diagrams and correlation coefficients. So if you don't have the data keyed in, I would encourage you to pause the video and key it in. You don't need to key in the age data. We just need the number of licensed drivers and the number of fatal crashes. So a total of 4 different lists in order to hold the data set. I believe I have it saved in my calculator. As you can see, I have the number of male drivers in list 3 and the number of fatal crashes for males in list 4, and so on. And so let's see what we're being asked to do here. In part A, it says to find the least squares regression line for males, treating the number of licensed drivers as the explanatory variable and the number of fatal crashes as the response variable. Repeat the procedure for females. So we're going to do 2 separate regression equations here. So I'll go back to the calculator, and I want to get out of this. Go to the Stat menu, go to the Calc submenu, and we're going to be using number 4, linreg. And for the first one, we're going to run it on the male data. So that would be list 3 and list 4 in my calculator. The regression equation is there. Typically, if I'm doing a problem like this on my scratch paper or wherever, I will note what you see right here on the screen, because typically we're going to be asking you about all 4 of those numbers. And so it's handy just to have them instead of having to go dig for them. But in this case, I'm just going to save this in the Y memory, the Y menu. So if you recall, you go to the VARs menu, you go to number 5, statistics, and then you go over to the EQ submenu, and you just press enter, and the regression equation will be stashed there for you. And we'll go back to the stat menu and we'll run the regression equation for the females. The data on my calculator resides in list 5 and list 6. There's the regression equation. And so again, we want to save that, but in Y sub 2, not Y sub 1. There you go. Let's see what we're being asked to do now. Part B is asking us to interpret the slope of the least squares regression line for each gender. And then they're asking how an insurance company might go about using that information. Now, one thing we want you to notice is that the number of male drivers and the number of female drivers is given in thousands. So 12, for example, would be 12,000. And likewise, 6424 would be 6424 times 1,000. So in other words, 6.4 million licensed drivers, and so on. That's important because if you recall, when you interpret a slope, you need to know what the units of measure are. So let's go back to the calculator. As far as the male drivers are concerned, I'm thinking I would probably report a slope like that to 3 places. That's probably more than adequate. And so let's look at the different ways that we can consider that slope. Now we can consider that slope as a straight ratio with the decimal value that we had there, 0.343 divided by 1. And that gives you, of course, 0.343, which is what we're reporting as the slope. But that's a little bit awkward to interpret because if you think about it, the numerator is basically 0.343, a fraction of a fatal crash. And the denominator is 1,000 male drivers. And so that's kind of a mouthful to articulate that. I think if we consider this ratio more carefully, we can find a more user-friendly form that would be easier to talk about. And so, for example, we could also write this as, 34.3 over 100 if you want. You can see it gives you the same decimal. And in this case, the numerator would be 34.3 fatal crashes, and that would be 100 times 1,000, so that would be per 100,000 licensed male drivers. You could also give the ratio as 343 over 1,000, and you can see that yields the same decimal as well. Of the 3, I think I'm most comfortable articulating the last one. It is the most agreeable to express. If you think about it, that's 343 fatal crashes, and the denominator is 1,000 licensed drivers. So in other words, 1,000 times 1,000 being a million, it's 343 fatal crashes per million. And it's a positive slope, which means it's increasing. And so if you ask me in 25 words or less to articulate what does that slope mean, I would say, well, for an increase of 1 million licensed male drivers, on the average, we would expect to see an increase of 343 fatal crashes. Now, the slope for the female drivers was 0.104. And so again, a couple of different ways we can render that. Let me quit this here. We could put it as 0.104 over 1. Of course, that would give you the correct decimal. It's again a little bit unwieldy to articulate that. I think I'd probably go for 104 over 1,000. And you can see again it gives you the same decimal. Remember that the 1,000 represents an increase of 1 million licensed female drivers, and 104 would be 104 fatal crashes. And so if you ask me to put this into words, I would say, well, if we see an increase of 1 million licensed female drivers, on the average we would expect to see a corresponding increase of 104 in the number of fatal crashes. Let's see what else we're being asked here. There was a follow-up question. They asked, how might an insurance company use this information? Well, the number of fatal crashes that the male drivers exhibit is roughly 3 times as many as the number of fatal crashes that are perpetrated by female drivers or that involve female drivers. And so I would charge, on the average 3 times more for the male drivers. It may be a little bit more complicated than that, because if you actually look at the data closely, the rate of fatalities changes according to the age. But anyway, on the whole, I would be charging more for the male drivers than I would be for the female drivers. Part C is asking, was the number of fatal accidents for 16 to 20-year-old males above or below average? Now, the number of fatal crashes for 16 to 24-year-old males, you have this number of drivers and you have that number of fatal crashes. So what they're really asking us to do is to find that in the scatter diagram and compare it to the regression equation and see whether it's above or below the regression equation. If it's above the equation, then it would be above average. And if it's below the regression equation, it would be below average. And if it's on the graph of the regression equation, it would be average. So we need to do some work on the calculator here. We need to graph the data and we need to graph the regression lines as well. Now I already have the regression lines saved and ready to go. What I need to do is to get my stat plots turned on. And so it looks like the first one is turned on. Let's see what that is. It's a scatter plot and it's directed to list 1 and list 2. So I'm going to change that. I'm going to leave it on, and I'm going to leave it as a scatter plot, but I'm going to direct it to list 3 and list 4. And as we did before, when we did this as a scatter diagram example, we used a box for the male data, and we used a plus sign for the female data. So I'll do the same thing. So I'm going to go up to the very top, and that's going to allow me to get access to plot number 2. And so I'm going to turn that on. And it's going to be a little bit busy, but it's all right. It's where we want it. Everything is in place. And so really all I have to do now is quit this, and I'll just do a quick zoom 9, zoom stat. And you can see it's going to graph both lines and the corresponding scatter diagrams. Now I think I probably want to clean that up just a little bit. So for the x values, I think I'll go from 0 to, as we did before, 25,000. With a scale of 5,000. And for the y values, I'll go from 0 to 10,000 with a scale of 1,000. Never touch XRes. Here's my graph. And so if you recall, the square boxes are the male data, and so this line right here is the regression model for the male data, and this line right here is the regression model for the female data. Now, we were being asked in the problem here whether the number of fatal accidents for 16 to 20-year-old males was above or below average. So what we need to do is to navigate that particular data set and locate that data value and see where it is in relation to the regression line. And so I would use trace, and you can see that at the top of the window here it's telling us that we're tracing information from list 3 and list 4, which is what we want. That's the male data. And then down here at the very bottom of the screen it says X is 12 and Y is 227. So right now it's looking at the first data point in that series of data, or in that data set. And if I use the right arrow key, it moves over, and that is right there the number of 16 to 20-year-old male drivers, 6424 if you recall. You can see it right here in the data set. Let me scroll up. Right there, 6424 5180. So when I go back to the graphing calculator, I can see the cursor flashing right here, and that point is clearly above the related regression line, and so it would be above average. Going back to the question, it's asking, well, what about the number of fatal accidents for males 74 years or older? Was that above or below average? So for 74, the number of drivers was 4803, and the number of fatal crashes was 2022. So I want to try to find that data value in the data set as well. And so I'm just keeping an eye on the bottom of the screen right here, and I'm looking at these values as they go by. And that right there, the very last one, that is the number of licensed male drivers 74 or older, and that is the number of fatal crashes. Now you can see the cursor flashing right there, and you'll notice that the point in question is slightly below the model. It's slightly below the regression model line. And so in response to that, we would say, well, it's slightly below average. Now they ask us to do the same thing for females, and there's a follow-up question here I probably should answer. It says, how might an insurance company use this information? Well, if you're an insurance company and you're looking at the data, you realize that for the young males, the incidence or the probability that they're going to have a crash is considerably larger. It's above average, so you charge them more. And it's below average for the males that are 74 or older, and so you'd charge them less. How to figure out exactly how to change what you're going to charge them, that's a subject for a different chapter, and we'll talk about that later, but that's all we can say right now. Now we want to repeat the same question for the females. So when you look at the data set, the number of drivers in that category for females would be 6139, and that's the 16 to 20-year-olds, and then 5375 for greater than 74. So again, we go back to the calculator, and we want to trace, but this time we want to trace list 5 and list 6. So you'd push the down arrow key, and you notice up here that now you're tracing list 5 and list 6, the second stat plot. And so I'm just going to motor through the data set here using the right arrow key. You know, it looks like I'm probably at the end of it actually. So 5375, I believe that's the number of, yes, that is the number of licensed female drivers 74 or older, 980 fatal crashes. So when you come back and you look, it's a little bit hard to see, but if you, let me blow it up on the large screen here. If you look very carefully, you'll notice that the cursor is flashing slightly below the line. And that would say that it's slightly below average for that particular age category. Let's go back and work our way through the rest of the data set. I believe that is the number for 16 to 20-year-olds. Let's check. 6139. So that is correct. No, it's not. One more. There we go. 6139 2113. Now you can see that point flashing right there. That is above the regression model line for the females. So it would be above average in that category for females as well. And so to respond to the question, how might an insurance company use that information? Well, they would charge more for the younger females and they charge less for the older females, same as the males. Hope that helps. Please click through to the next video and we'll show you one more example of linear regression in action.